We finished our last video talking about graphing this polynomial. We understand where the zeros are. We understand the degree of the polynomial. We get this idea of the behavior around the zeros of the polynomial based on the degree of each individual factor. The last thing in the video that we ended with was understanding that this thing right here, what we call a power function, dictates the end behavior of my polynomial. The highest degree term of the polynomial dictates your end behavior. But if you think about it, I'm not going to take a lot of room right here, but if I wanted to graph x to the 6th, what would it actually look like? Well, at 0, I would get 0. At 1, I would get 1 to the 6th, which is 1. At 2, I would get 2 to the 6th, which is 64. And it'll look like that. If I look at negative 1 to the 6th is positive 1. Negative 2 to the 6th is positive 64. And it'll look like that. Which looks exactly like a parabola. So this is a 6th degree and it looks like a parabola. If I arbitrarily changed it to an 8th degree, what would change? Well, it would get a little bit bigger, a little bit faster, but it would still be positive on this side and positive on that side because of the even degree. It would look like a parabola, which really just means, from a power function perspective, the degree of the power function will dictate what the graph looks like. Even degree ones look like parabolas. If I arbitrarily tried to graph f of x equals x to the 7th, an odd degree, well, if you think about it, at 0 I get 0. At 1 I get 1 to the 7th, which is 1. At 2 I get 2 to the 7th, which is 128. It goes up like that. If I plug in negatives, at negative 1 to the 7th is negative 1. Negative 2 to the 7th is negative 128. And it looks like that. Well, that looks like a cubic. So essentially, if you want to graph a power function, all you do is look at the degree and whether it's even or odd. If it's even, it will look like a parabola. If it's odd, it will look like a cubic. But then we know the end behavior of parabolas and cubics. Parabolas either both go up, or if it's flipped, both go down. Cubics either go from bottom to top, or top to bottom, if they're flipped. So now, what we're going to do to graph this function is basically just draw little arrows like that. We're going to say, okay, this is a 6th degree polynomial. It's even. The end behavior has to look like a parabola, which means that either both goes up or both goes down, just like a parabola would. How do I determine if it goes up or down? Well, we said when talking about parabolas, the leading coefficient dictates if it's regular or flipped. So all I do here is look at the leading coefficient. In that case, it's just 1, which is positive, so it'll look like a regular parabola. A regular parabola looks like that. Now I have the end behavior of my graph, these two arrowheads. I have the zeros plotted, and using this idea about the behavior around the zeros, I can graph my polynomial. All I do is connect the dots. I start here. I have to go down and hit my first 0. At this 0, I simply look at the degree. X minus 7, that's negative 7, which is x plus 7. The degree there is 1. If the degree is odd, you cut through the axis. So I go down. But if I go down, I have to come up. Negative 4, that's x plus 4. That's odd degree, so I have to cut through the axis. So I go up. But if I go up, I have to come down to this 0. At 2, x minus 2 is an even degree. I bounce off the axis. So I just come down, I bounce off. But if I go up, I have to come down again. At 5, that's x minus 5, even degree. I bounce off the axis, which is good because then, assuming I can draw straight, I match up with the arrowhead there. And there's the graph of my polynomial. I would stress when doing this, plot your end behavior, your arrowheads, based on the degree, plot your zeros, and then connect the dots using this rule about the behavior around the zeros. If you do it right, you should meet up with the arrowhead where you're supposed to. If somehow I was graphing this, and I ended up down here, and the arrowhead was up there, then don't just go, oh, there we go, now it matches up nicely. If you end up in the wrong spot and you can't get to the arrowhead you want to, go back, check your zeros, check your behaviors, make sure you sketch things correctly. Because this has to work out correctly. So, we will do one or two more of these. Suppose I have f of x equals negative 2, x minus 3 squared, x plus 4 squared, x minus 5. First off, what's my degree? We said I just count the degrees of the zeros. There's 2 there, and there'll be a 1 right here. Don't worry about that. That's just a constant out in front. There's no x there. That doesn't affect the degree. So 2 plus 2 plus 1 is 5. That's my degree. Now, let's see. If I plot my zeros, I have a 0 at 3. We'll say it's right here. I have a 0 at negative 4. We'll say it's right there. And I have a 0 at 5, which we'll say is right there. Now, I look at my end behavior. This is a 5th degree, which means it looks like a cubic, and the leading coefficient is negative, which means it's a cubic that's flipped. Normally, if we think about a cubic, they look like that. They go from bottom to top. If I flip it, it goes from top to bottom. So, I start up top, I go down bottom. Now, I connect the dots. I start up here, I have to come down and hit this 0. At negative 4, that's x plus 4, even degree bounces off. So I go down, I go up, I come down. At 3, that's x minus 3, even degree bounces off. So I go down and come up, but if I come up, I come down. At 5, that's odd degree, cut through the axis, so I cut through, which is good, because it connects me with the arrowhead I'm supposed to get to. This seems incredibly simple. I mean, draw a couple of arrowheads, plot some zeros that you're given, and then connect the dots. That's all it is. Don't try to overthink this or make it really complicated. These things are nice and straightforward and simple. Draw a couple of arrowheads, plot some zeros, draw some dots, and then connect the dots, just like when you were a kid. We are going to do more with this, like I said in the last video, but in order to do more with this and look at polynomials that are not factored, we need more algebraic tricks that we don't have yet. So the next few videos are going to be on those algebraic tricks.